Total, did you have a count? How many people are there for this protocol? Anybody knows? Hello? If you type something, I could not able to focus on that. So try to be interactive. Okay, sir. So today we'll start just introduction only. So from the next session onwards, we'll be starting the complete thing. So we'll just see why we need this I2c. Before going to that, just I'll introduce myself. Okay. So I'm Shashank. I'm from Bangalore branch. So I'm the branch manager for Bengaluru Institute. So I think you have known it already. Like we have our branches in Hyderabad, Noida, and Bangalore. So I'm the branch manager for Bangalore. So I'll be taking you this AXI design project. So there in Bangalore branch, I used to teach all the modules like digital Verilog, system Verilog, and UVM as well, and projects like different Ethernet and some other projects. So they asked me to take I2C design project. So we'll be doing it. So by this month end, we have the timeline. So from 15th to 31, I guess. So I have made a clear schedule of it. So daily we'll go according to that schedule only. Okay, so today we'll just see the introduction. So how the protocol design will be done, like what and all things you need to keep in mind, and what is the category of the protocol which you are going to do. Okay, so hope it is clear. So I can see only one is responding. What happened to remaining? Remaining. See, this is it should not be like this, guys. You should not sit simply. You have to interact. If I got response from all of you, then only I'll start class, or else I won't start. Still, still nobody is unmuting their self. So you have completed Verilog, I guess, right? Okay, then we'll wind up the session. Okay, we'll meet in the next session. So you can leave now, no issues. Today's session, right? So I'm going to explain what is the protocol and this all things. So generally, when you are now completed your Verilog, so once you have completed your Verilog, so you need to complete your design project, RTL design project. So what do you mean by developing a project like by using Verilog? Simply nothing but what you are going to do. So this Verilog is a nothing but HDL language. By using this HDL language, you are going to build a behavior of a circuit. Okay, so you need to build the behavior. So for example, if there is an IC, for this IC, so first what you need to know, you need to understand the block diagram, how many inputs will be there, how many outputs will be there, what is the control signals we have, do we have any clock or not, or if we have clock, what is the clock frequency we have, if we have reset, what kind of reset we use, what is the width of each signal, input signal, and is there any dependencies. So these all you need to understand, then only you could able to write the functional description. Hardware description language is nothing but why we use to build a functionality. Okay, so to describe the hardware circuit functionality, in we use this Verilog HDL. Okay, so nothing generally. So why we need to go for I2C or any other different projects which your friends have been allocated to different projects. So first of all, we'll understand why we need to have a protocol. What does it gives? Generally, what is meant by a protocol? For example, so you are in a traffic signal. Okay, so this is a road actually. Okay, so a four-way road or something, whatever you can consider like this. There is a junction. Okay, so people will go from here and here. Okay, so for example, you cannot randomly go. For example, you are in this particular position. You cannot simply go to this particular right. Okay, this location you cannot immediately. You have to follow some signals here. Okay, so by observing those signals only, so then only you are meant for to going this particular thing. So nothing but, so what we generally do in an RTL. Okay, so RTL is generally stands for what actually, register transfer level. So that means you are going to develop any protocol or anything. Okay, you are going to develop a particular design. So in that design, what is actually happening? Registers are going to transfer. Okay, so the data between the registers, how it is transferring, on what conditions it is transferring, and on what speed it is transferring, on what dependence it is transferring. So that is nothing but your RTL design. Okay, you are going to model a design. Okay, so that in terms of register transfer log, in terms of registers, how they communicate with other registers. So generally in any protocol there will be bunch of registers. So how these registers will be transferring the data, that is nothing but your things. Okay, nothing but a protocol is nothing but, it's not a project actually. You are going to build what actually. So protocol gives a proper idea of what you call building the dependencies between registers, building the dependencies between registers. Okay, and what it will sells. You are also going to build, okay, uh, some rules or regulations or what conditions. Okay, these are all you are going to say. Generally, protocol is nothing but a set of rules and guidelines how registers used to communicate. So that you are going to model. For example, if you take I2C, how the data transferring will be happening. If you take an SPI, how the data transfer will happen. If you take a USB, how the data transfer will happen. So these all are nothing but what USB, PCI, Ethernet. Those are some standards. Okay, actually internally the same functionality will be there. Nothing but registers transferring the data. But how they are transferring. So depending on that, we have these all the protocols like I2C, SPA, IMBA protocols. These all are nothing but those standards only. Okay, so generally when we talk about the communication, right, protocols, so there are different kinds of what you call protocols. Okay, so we generally have communication protocols with us. Okay, we have communication protocols. We have bus protocols. Okay, so we have network protocols. Okay, and we also have what we call a frame based protocols or different things which we have, application based protocols like this we have. So now for example, in communication protocol, right, so again we have it as a serial communication protocol as well as parallel communication protocol. Okay, so these bus protocols are nothing but all AMBA protocols. So where we need to have some kind of memory access. So there we use bus protocol generally. So in that we have APB or AHB or AXI. So these all comes under this bus protocols. When we go for the network protocol, you might already have learnt it in your BTech, I guess. Like you will be having what this subject DCN. Okay, data communication networks or something you'll be having. There you will be having encryption, decryption, and some blowfish algorithms will be there. So and cipher text keys. So these all things will be there, right, in digital communication network. Similarly, that is nothing but your network protocols. So you will be having TCP/IP network protocol, file transfer protocol, DNS. Okay, so these all are belonging to the network protocols. Okay, so now whatever the protocol which we are going to discuss, like I2C, that comes under communication protocols. This one. Okay, in this again you have serial and parallel, right? So the I2C belongs to serial communication protocol. So I2C is a serial communication protocol where the data will be transferred between one component to another component serially. Bit by bit transfer will be happening. Okay, so only one bit will be transferred the single pulse clock. Okay, so that's is nothing but an I2C protocol. So this is just a basic of this. And next we need to understand what transmission types. Okay, so the communication involves transmission only. Inside that we have transmission. So what are the different types of transmissions we have? Okay, so the first thing we have is simple. Okay, simplex, and then we have something called as half duplex, and then we have something called as full duplex mode of communication. Okay, so these are the three types of transmissions. Simplex transmission will be there, half duplex will be there, full duplex will be there. In simplex mode of communication or transmission, what happens always? So you need to understand when I have told you the transmission, there will be two components involved. Okay, so that is nothing but TX, and there will be something called as RX. So TX stands for transmitter, RX stands for receiver. Okay, so in simplex mode, what will happen? The data transfer will be happening, okay, between transmitter to receiver. Okay, but you won't get any data back from receiver to transmitter. Only one way communication is possible. So that is simplex mode of communication. If you want an example of this, it is simple, nothing but your radio communication. Like FM radio will be there, frequency modulation, this thing, radio. So you'll be hitting 96.18 something. So those and all are nothing but what actually they can, whatever they are speaking in the studio, that you could able to listen. But if you wanted to talk, it is not possible with them. So that means only one way communication will be there. So that is nothing but simplex mode of transmission. And the next thing we have is half duplex mode of transmission. In this half duplex mode, what will happen is it is just an improvement done to the what actually simplex mode. Okay, so here also same we have transmitter. Okay, and then we have receiver. But what extra we add is we have this path also. Okay, here only one way direction, right? It is a bi-directional one. Okay, so transmitter can send data to receiver, and receiver also can send back the data. But what is the problem we have is, so both cannot be done at the same time. Okay, if this is done at T1, this should be done at T2. Okay, both cannot be done at T1. So if you take an example of this, you have a walkie-talkie, right? So generally we see it in soldiers using it, walkie-talkies. In that walkie-talkies, what will be happening? So they will set a frequency between two particular walkie-talkie devices, and only one person able to communicate. One device can be able to transfer, and the other device should be in receiver mode. Okay, and when the receiver want to send, the other device should be silent. They should not speak anything. So, but bidirectional way of communication is possible, but it is not at the same time. So that is done in the half duplex mode, and in the full duplex mode. So this is an improvement done to the half duplex mode. So that is nothing but, so here bidirectional communication will be possible at same time, simultaneous. Simultaneous uh, bidirectional communication is possible in the full duplex mode of transmission. Okay, so both receiver and transmitter can communicate with each other at the same time. So this is nothing but normal your mobile communication. Okay, so you can talk with your friend at the same time, and he can also speak with you at the same time. So that's nothing but a full duplex mode of communication. And now, out of these all three, so which where I2C belongs? Okay, so I2C belongs to what actually? So that's the second category, which is half duplex mode of communication. So I2C is not a simplex mode of communication. I2C is nothing but The full form of I2C is nothing but inter-integrated circuit. Generally, this I2C is nothing but used to connect the peripherals to the microcontroller or microprocessor or any kind of CPUs. Okay, so to connect the peripherals means anything. It can be sensor or it can be or any kind of peripherals like some low speed protocols will be there, right? So small things, JTAG or UART, anything. These all protocols, to connect these protocols with the this kind of CPUs, GPUs, we need a barrier, we need a bridge actually. So I2C acts as a bridge between your low speed peripherals to the microcontroller or microprocessor. Generally, you can see lot of I2C, what you call I2C uh, uh, protocol used in embedded systems. In embedded systems, there will be all peripherals only, like Arduinos will be there, JTAGs will be there, and some other DSP modules will be there, clock generator, oscillators, these all things will be there, right, in a chip. So to communicate with all these chips with the main core, you will be having microprocessor and Arduino board. So like 8086 microprocessor, 8085 microcontroller. So from the data from microcontroller to peripherals and vice versa, peripherals to microcontroller can be done by using I2C protocol. Okay, so the way which is nothing but half, which it uses half to flex mode of communication. Okay, so I2C stands for. So hope you understood. Are you able to understand? Yeah. So inter-integrated circuit. Okay, I2C stands for this thing, inter-integrated circuit. Okay, I2C means what actually? Double I. Okay, I2 means double I and then C, inter-integrated circuit. This is nothing but to connect. Why we need? So I2C acts as a bridge between peripherals and microcontroller communication. Okay, so we need I2C to establish a barrier between microcontroller or microcontroller or microprocessor. Okay, new microcontroller, microprocessor to the low speed peripherals. Okay, so there we use an I2C generally. So almost it's mostly widely used in embedded circuits actually. Like for example, when in your cars, right, you can see the ADAS circuitry. Okay, so nowadays it's the most what you call it, a building technology, ADAS. Okay, that is nothing but it will assist the driver. Okay, so driver assistant automating system or something, the full form will be there. So what it will do, lane control it will do. For example, when you are in a ORR on some big highways, right? So automatically that ADAS, right, it will have the lane control system in this. ADAS level 1, level 2, level 3 will be there. In the level 1, right, you will get a basic features like cruise control, something. Okay, when you're riding in a big lane for 600 to 800 kilometers, right? Always you need to press the accelerator. Instead of that, if you wanted to have a sweet point, like you wanted to maintain a 60 to 70 kilometers average, so then what you'll be having? So you'll be having cruise control option. When you use that cruise control option, so the limit of that car will be maintained 60. So if you wanted to remove that, immediately you can remove. So that feature, and we also have lane control systems, and we also have parking assistance. Like once you click the parking button, automatically the car itself will uh, estimate the given space and it will park automatically. So these all are nothing but ADAS features. So inside that ADAS also, one of the key component we use is I2C. Okay, inside that ADAS, you'll be having a lot of sensors. So how the car itself will park? There are a lot of infrared IR, what we call is sensors. So to and you'll be having a central microprocessor. So to that processor, these sensors need to be send data. So this communication will be done with the help of I2C. Okay, not only in this application, so there are different types of applications we can see where I2C can be used. Okay, so why only I2C can be used? We also have better feature, better protocols compared to I2C, but still it is an outdated protocol. Yeah, it is an outdated protocol, but see what exactly happens. For example, so BMW, and if we compare Maruti Suzuki, so Maruti Suzuki people are buying and BMW are also people are buying. But the cost, if you see, whatever the accuracy that BMW car gives, your Maruti Suzuki won't gives. Okay, so how does accuracy comes when you use all accurate devices only, right? So now in BMW they might use the latest protocols, okay, and in the Maruti Suzuki still they use this I2C protocol. Okay, so that doesn't mean I2C protocol is not using these days. So wherever you need, it depends upon your application. If your application is limited to only this much things, then why we need to spend more and more money on buying new protocols? I2C will do, right. So in that cases, I2C can be applied. Okay, and the market also need to show some difference, right? If whatever the sensors they're using in Maruti Suzuki, if the same sensor they used in BMW, then what is the point? Simply you are paying for brand. They need accuracy. Accuracy comes on the latest generation technology. So there also you can use this. So, and there are wide different applications of your I2C. So we'll slowly see one by one. And the main advantage why I2C can be used compared to other protocols are nothing but the hardware circuitry will be very simple. Okay, the I2C hardware circuitry will be very simple. Why it is very simple? Because it has only two pins. Okay, it have only two pins. There are only two things. One is for data, and one more is for clock. With these two signals only, the data transformation can be done in the I2C. Whereas if you go for any SPI protocol or DR protocol, there will be a bunch of signals. When you have more and more signals, what will be happening? The dependencies will be more. If the dependencies are more, right, then what will be happening? So the hardware circuit becomes complex. It will occupy more and more area, right? So that's what you are going to, that is also one of the advantage of I2C. So less pins will be there. So if you have less pins, obviously, so hardware circuitry will be very small. So you can use it in wherever the space, you can save the space, right? So, and there are different what you call features of this. So we'll slowly go when we are discussing a particular concept there. So generally, I told you now. So this what we call half duplex, right? I told you half duplex mode communication is nothing but I2C. I2C is it uses half duplex mode of communication. Now in half duplex mode, we have a transmitter and we have a receiver, right? This is the things. But actually, how it looks, so there will be a devices. Okay, this is a device one. Okay, and there will be another device which is called as device two. Let us see. So now what happens, right? So this device, okay, will have two things. Okay, one is a transmit, what you call transmitter, and one is for receiver. And here also same, you have the transmitter block and you have the receiver. Now how we will connect? So the data from this transmitter goes to this receiver, and the data from this transmitter goes from this thing, right? This is how the data transfer will happen, where in case of anything, okay, any devices, okay, it may be we call sometimes it is a host. Okay, this can be called as host, this can be called as master, or it can be called as controller, or it can be called as what you call local device. Okay, local station also. And here we can call it as what device. Sometimes if we use host there, we have to call it as device. If you use master, we have to call it as slave. If you use controller, this will be called as subordinate. If you use their local station, here we have to use the remote station. Okay, there will be different terminology according to the specific protocol specification. But in I2C, the terminology we use is master for D1, device 1, and slave for device 2. Okay, this is nothing but master, and this is nothing but slave. Okay, so in I2C, generally I2C is nothing but, so there will be master and slave. Okay, master as well as slave. How many masters will be there? How many slaves will be there? Okay, so it depends upon your what we call chip specifications. Okay, it depends upon your chip specification. We don't have exactly number. I have two masters, I can have two slaves. No, it won't be like this. Okay, so it can be single master, single slave based upon your application, or it can be multi master, multi slave. Okay, so it can be single master and single slave, and it can also be multi master and multi slave. So this is the advantage. Okay, so I2C can be operated in single master and single slave, or it can also be operated in multi master and multi slave. So you can see what is meant by multi master, where we require. So for example, let us assume that there are two masters and there are two slaves, right? So now let us take the same some automobile applications. For example, in the recent days, when we buy a motorcycle, like any bike, if we buy, right, like any bike. So whenever we applied this, what actually side stand. Okay, whenever we use side stand, right? So the bike will not start actually. Okay, when we remove side stand, then only the engine will get ignited and we can what we call drop the clutch and we can go. But whenever the side stand is activated, that means you have applied. So then if you try to ignite your engine also, it won't work. That means there is a sensor here. Okay, let us take this sensor, right? And there will be another thing called as what we call it as mm, modes actually inside a bike, right? There will be mode. For example, you will be having a normal what we call rain mode. You will be having. Okay, you need to select the terrain. So terrain is nothing but the type of road. If it is a mountain, right, we call it as half road. If it is a normal highway, okay, then no need to turn on the half road. It is a different terrain. So if you are traveling in near some kind of guard road, so it will be different terrains. Okay, so there will be rain mode. Okay, there will be street mode, and there will be some kind of highway. So like this, we have a different highway. So what it will control. Okay, so what it will does is, so it will control you. We generally bike has two wheels, right? So front wheel and back wheel. So now, for example, if your front wheel is in rotating in different RPM, revolutions per minute, and if your back tire also is different. Okay. For example, if this is not equal to this one, then what will happen? Probably this scenario is possible when you're doing some kind of wheelies, like people will lift their front tires, right? So that is possible. Okay, your front tire RPM does not equal to your back tire RPM only in cases such as you might have done accident, or you might have doing some kind of wheelies. Other than that, it is not possible. Okay, so your front time RPM and back time RPM should be equal. Okay, so now sometimes due to some road issues, or road is not proper, road is damaged, so your front tire and back tire will not be in the same RPM. So that what will be happening? Okay, it overall it will affect the rider what you call riding quality. So for that we have a this kind of things. Okay, so what they will be doing? So there will be a sensor. That sensor monitors both RPMs of front and back, and will try to maintain the same revolutions per minute from front end and back end. Okay, so that's how it helps generally. So this, let us take, this is also one sensor. Okay, so RPM sensor. Okay, now these two sensors we have. This is a normal side stand sensor, whatever we discussed earlier, and this is a second RPM sensor. Two sensors we have. Okay, and now this sensor will communicate to microcontroller. Okay, and this sensor will be RPM sensor will be controlled to microprocessor, right? So in between microcontroller and this particular side stand sensor, so you will be having I2C, and between microprocessor and between this RPM sensor, there will be having again I2C. So that means what you need to understand, these are masters. Microcontroller and microprocessors are what actually masters, and this side stand sensor and this RPM sensor are nothing two slaves, slave one and slave two. Okay, so that's how we call it as multi-master and multiple slaves. Right? Understood? So your I2C will have only two pins for communication. Okay, so what and all those pins we have? The first pin as SCL and the second pin as SDA. Okay, SDA. So STL stands for serial clock line. Okay, this will stands for serial data lane. Okay, these are the two signals we have, SDA and SCL. So your microcontroller to sensor will be carried out by using only this clock. Here we use clock for what actually? For synchronization and other purpose. The actual data will be sent in the SDA. SCL is a pulse actually. So you will generate clock rate by using always at the rate, always hash file not equal to hash file. Like this you will write clock. So that is nothing but a pulse. So SCL is a pulse actually. It depends upon the peripheral frequency. Okay, and SDA is nothing but the data. So how much data you are sending, on what dependencies you are sending, what is the data rate you have. Okay, so those all things will be done inside the SDA, right? So only two signals will be there, this particular things. And next, what we have is, okay, whenever you turn on your mobile data in your mobile phones, right? So you can see a speed which is displayed on your notification bar, right? So probably it will show you 1.14 kbps, 2.4 mbps when you connect it to fast Ethernet. So it will be showing, right, some speed. So tower symbol will be there like this. Okay, and then here it will be showing 14.2 kbps. So like that it will show you whenever you turn on mobile data in your phones. So what is this? What is this 14.2 kbps? Okay, this is called as data rate. Okay, this is called as data rate, DR. Okay, how this data rate is calculated? Simple. So data rate is equal to number of bits you are sending. Okay, number of bits you are sending into clock frequency. What is the clock frequency you are using and what is the number of bits? Okay, when you multiply these two, you will get the data rate, right? So similarly, I2C have what we call four different types of data rates. Okay, I2C data rate. Okay, first data rate. So we have something called as standard data rate. Okay, I2C have standard data rate. So which is, what is the data rate of this is nothing but, so you can transmit 100 kbps, kilobits per second. If I write K capital B, then you need to understand that it's kilobytes. Okay, but here it is only kilobits, small b, kilobits per second. Okay, so this kbps is nothing but, kbps is nothing but data rate. Okay, how many bits per second here? That is nothing but clock frequency. Okay, and the second what you have is, so you have another data rate which is called as fast mode. Okay, in this fast mode you can send 400 kbps. Okay, and we have next one which is fast plus. Okay, where you can send data up to 1 megabits per second. Okay, 1 megabits per second, 1 mbps, small mbps. Okay, so and then the fourth one you have is high speed or high mode. Okay, where you can transfer data up to 3.4 what you call megabits per second. So these are the different data rates we have for the I2C protocol. Understood? So I2C can be operated at four different modes. We can operate it in standard mode where the data rate we can get it is 100 kbps, or we can either operate it in fast mode where we can get the data rate of 400 kbps, or we can operate I2C in the fast plus mode where up to 1 megabits per second speed data rate we can get, and we can also operate I2C in the high mode where 3.4 Mbps will be the highest one. Okay, so this is the highest standard. Last one will be the maximum speed or maximum data rate where you can use I2C. So now tell me, so wherever you require 3.4 Mbps, there, why you need to go for other protocol? I2C is serving you 3.4 Mbps, right? So typically I2C can be used there. Understood? Only for one, what we call, for Shashivardhan Reddy, it is understood. And what about remaining? Then Gnapika, why you are not responding? You can unmute yourself. Is that an option available, right? You can unmute yourself. You can talk back. Still, you are not opening your mouth, sir. See, I won't ask any questions. You don't need to worry. I just wanted to have some interactions here. Then only it will fuel up for me. If you are sitting silent, then I could not able to give my complete expertise on this. So now fastly list the key features of this I2C. Fastly, just put it in the chat box. Whatever the key features you have still now, key features. So you understood, right, where we have to use I2C. Okay, so now you list some key features, whatever we discussed. So the first point is I2C is a what somebody have, yeah, it is half duplex. Good. Next, I2C uses half duplex mode of communication. Then, so we'll write it. Okay, so you need to list it out. So, okay, it is a serial communication protocol. Okay, so the data will be transmitted bit by bit using what SDA. Okay, signal. This is signal. Serial data line signal. Okay, so I2C uses half duplex mode of communication. Good. Next, it have multi master and multi slave configuration. So number of master and number of slaves can be depends upon chip specification. So not the I2C. When you have the SOC level, right? So inside that SOC level, so you will be having different things here. Okay. So this is a chip actually, chip top. So according to this specification, how many masters are there, how many slaves will be there, you'll get to know. Okay. Based on it, you can have two or three masters, or up to the maximum masters you can have is till date, it is 16. Okay, so there is a limitation in a chip motherboard or whatever the chip you are using, right? So there we are in a generation of using only 16 masters. Even if you go for AXI or if you go for any other AHP also, so there also you will be having 16 masters. Okay, because it is a chip, what you call limitation. And what else we discussed? So it has only two pins, right? So which are SCL and SDA. Okay. So what will happen? Hardware will be simple, right? And then what is other thing we have? I2C, it can be operated, right? It can be operated at different data rates. Different data rates. Starting from what the minimum is 100 kbps, maximum of 3.4 megabits per second. Okay, so you can use any of these speeds by configuring it. Yeah. And next one, what it is this I2C is right. It uses a frame format. Okay, I2C have frame format for data transmission. Okay, so you are not you are sending data bit by bit, right? So now there will be a structure how you are sending the data. Okay, there will be address with that. Okay, so you cannot simply send the data, right? So when you have multi slaves, each slave is allocated with some kind of address. Okay, so maybe slave one will have address from 0 to 20, slave two will have 40 to 60. So now your master want to write some data in 60 location. In that you cannot send the data to first slave, you have to select the second slave. So okay, then that frame will be there, how based on address how the data will be transferred. Okay, so you will be having a start bit, then followed by you will be having 7 bits of address, then you will be having again read or write operation, single bit, then you have acknowledge signals, acknowledgement and non-acknowledgement, and then you have data frame one, and then you have again acknowledgement signal, and then again you will be having data frame two, and then again you will be having acknowledgement, and again you will be having a stop bit. Okay, so there that frame format we can see it. Okay, so it's a frame based protocol. And if you take Ethernet, there also you have a frame based one. If you take PCIe, there also you have frame. If you take UART, frame. If you take SPI, frame. So mostly serial communication protocols will be frame based only. Okay, so this frame based protocols have high what you call high what your high weight in your resume also. Okay, so because once you understand any frame based protocol, right, so you can upgrade it to another version. For example, if you know I2C, you can easily understand USB protocol. Once you are good at understanding USB protocol, you can easily understand Ethernet protocol, then PCIe. So like that the kind of the legacy continues. So we will try to understand the frame, okay, in the next class probably. So by that, what I need you to have is you try to gather some information about I2C. Okay, what with whatever the things which I have shared you right till now. So you can use this, but I want you to make. Okay, so when you try to gather some information only, you will able to gain some new things. Okay, whatever I have uh, taught to you, you should not stick only to that. You have to think apart from this, do are we missing any points? Okay, so try to download some research papers on I2C, where exactly it is using, on what applications we can use it, what are the standards we have to follow, why only two signals are permitted in SPI or in I2C, why we cannot have more than those signals, and do we have any specific reason of why we are choosing I2C only rather than any other things? So you can just go through these all questions by yourself, so that you will be understanding the basic overview of I2C. Okay, you don't need to go depth. Okay, today only you don't need to start write code. I think okay, no need to develop it from today only. Okay, we have this 15 days. Slowly we'll go step by step. Okay, so we are not going to implement all the features in a single day. First of all, you need to understand the basic features. Okay, this is a feature. For this feature, how we have to write code? We'll write code for only that particular feature. Once it is working, we'll write a corresponding test bench. We'll test it. Once it is verified and working fine, then we write the RTL version 2, where in that versioning you will be having a new feature. Once it is also verified, then we'll make another version of RTL. So that's how industry flow will be there. Don't think that all features will be developed at a single time. No, it cannot be developed like that. Concurrently, design team and verification people concurrently they'll work parallelly. Once RTL team have released their first RTL, it won't have all the features. For example, if we have the specification says there are 500 features inside this protocol, 500 features at a time only they won't create. Okay, first of all, they'll write 20 features and they'll release the initial RTL. So now what verification people will do? They'll parallelly develop the test bench for only those 20 features. They will verify. Meanwhile, design team will upgrade that initial RTL to next version, where along with the old 20 features, they will be adding again 10 or 20 features. Again, once it is verified, they will be versioning it. Okay, in the same manner, we will also be going. Okay, no need to implement the code from the day one only, but just see for a freshers, right? So rather than developing the entire code, it's main important for understanding where exactly it is used, why only this is used, why if you are using I2C, why in this particular configuration only you are using, why you are not going to that configuration. This kind of questions will be most asked. Okay, instead of they won't ask you write the entire master code or slave code. No, it won't be asked. Okay, so they will be asking you why. Why this protocol? Why not that protocol? Why this speed? Why this configuration? Why only two signals? Why it not be four signals? Why SCL? What is the importance of SDA? What is the frame format of I2C protocol? What are the limitations of it? Where we need to use it? Explain a real-time scenario where you have seen I2C. So this kind of questions you will be asking. Okay. So try to put some effort from your side. So download some research papers or download some specifications from your browser. So try to see it. You don't need to from the day one only. You don't need to what you call to quantify everything. Just try to make some notes of it. Okay. So in the next sessions we'll upgrade it. Okay. Is that clear? Yeah. So some people have written here good. So it is half duplex, correct? Multi-mast and multi-slave support. Super. Can reduce the usage of number of pins for communication between the devices. It can support various data rates. Good. Super. And next, 100 kbps to 3.4 Mbps. Good. Good. Yeah, this should be done. So list down the key features and also try to gather some more information. Okay. So try to download the research papers. Okay, so research papers and some reports or any other specifications if you find to download. Later I will send whatever what do I have, but I wanted you to do it first. Okay, when you explore only you will get to know. If someone have made the work easier for you, right? So it won't be that much interesting to you. Okay, so first you try it, then I'll help. Is it okay? So my way of teaching will be like this only. Okay, so any any doubt in this or any concerns or any complaints? Is it what I'm saying is understood? Like, did you understood or do you have any problem with that? Understood. Yeah. I think mic option is enabled for you all guys. Say tomorrow also, if you are not speaking right, then I'll cancel this. I'll hand over to some other people. You have to speak. See, for a fresher, right, what industry will see is that only. Like for example, if I'm your manager, right? If I have given you some task, I know you have done I2C protocol, but I want you to develop a test case for this scenario. So you never seen that scenario. I have given to you. You cannot say no, sir. I don't know this how to do. No, you cannot say. Okay, when I have given any task to you, what I'll check, if you don't know, are you gathering any information from the superiors in your office, and are you able to communicate with them regarding this, and with them, with that, with their help also, are you able to do or not? That only they'll check. Okay, the interaction only they will be checking to you. So for a fresher, right, when they go to any company, they'll do the same. First thing will be like this only. The first phase will be documentation. So they'll be asking you to do the documentation for this protocol, that protocol, everything. So you don't know where the resources will be there, but I cannot tell you. My intention is to check what is the thing you will do. Okay, so that will be done only through interactions only. Be interactive. Okay, anything else? Okay, then you can leave. We'll meet on the next session. You can leave, guys, no problem.